Hello everyone, today in this video we'll be discussing the module 5 of DSA. All that which you need to know from the module 5. There are 6 questions in this module which will be discussed, and these questions are the most repeated ones, so don't miss any of them. And before starting, please do like and subscribe, it helps me make more videos like this. Without wasting more time, let's get started. The first question is define hashing. Okay, we have to define hashing. Explain the different hashing functions. Okay, this is the most repeated question of module 5 with example, and discuss the properties of good hash function. Okay, what is hashing? Hashing is nothing but it's a technique for mapping keys to values. Okay, with example, if I show, you'll be able to understand what it means. Okay, hash functions is used for that. Now, the types of hash function. The next question there is explain the different types of hashing function, right? So the different types of hashing function are, the first one is division method. Okay, now basically what is hash? See, we have some numbers to insert. Okay, what we have some numbers to insert like 54, 61, 78. In which place should we insert? Okay, that is the question. Only 10 places are there, from 0 to 9. 10 places are there, we have to insert in those places. Which place we will insert 54, which place will insert 61, that's the question. Okay, so what we basically do is, in division method we will be finding out the remainder. Okay, we'll be dividing by the size of this thing, and we will be dividing with that and finding out the remainder. 54 divided by 10 is what? It is, the remainder will come as 4, right? So when we get 4, in the fourth index we'll be placing 54. 61, we have 61 modulus 10. That means what is the remainder when we divide 61 by 10? 1 we get. So in the first index we will store 61. So like that we will be finding out where to store. Okay, so this is the hash function, and the method is division method. Okay, second method is mid square method. Okay, here we do k square. So suppose calculate the hash value for the keys 1 2 3 4. 1234 we have to calculate where we have to store, and that hash table has 100 memory locations. So 100 places are there from 0 to 99, and which place we will store 1 2 3 4 if we use mid square method. So in mid square method what we do is, we'll be squaring this one. Okay, we'll be squaring it. When we square it, we'll be getting this value here, and the middle value is taken. Okay, if we remove the 3 from here and the last 2 from here, we'll be getting a middle value. That middle value is taken, and 1 2 3 4 is placed. So the question won't be asked about mid square method for any question. You just have to write the theory, memorize this same example. The third one is folding method. Okay, so suppose that they give, calculate the hash value for the following 5 6 7 8, where we can store 5 6 7 8. What you do, divide this by 2. Divide this by 2 means 56 and 78 will get. Add them up, what index you get, that is your answer. 3 2 1, divide 32 and 1 here. Okay, always take 2 from the left. Okay, so 32 plus 1, 33. In 33 index will be storing 3 2 1. Here 34 plus 56 plus 7, what answer we get? 97. So it will be stored in 97 if you use folding method. So which are the three methods? First is division method, second is mid square method, and third is folding method. And properties of good functions: a hash function should hash address such that keys are distributed evenly as possible. Okay, it should be not uneven, it should be evenly. How much well we distribute, that is the good hash function. Okay, and computation of key should be simple, it should not involve complex calculations. Okay, just finding out the remainder or squaring it and taking the first the middle two digits, these are the simple ones. Okay, so any hash function which you design, those should have these two properties, then it is called as a good hash function. Okay, so memorize this question very well, it's a very important one. Moving on, we have the second super important question, which is define leftist tree. Okay, this is also most repeated one. Give its declaration in C. Okay, and after that we have to check if the binary tree which is given is leftist or not. Okay, so what is a leftist tree? It is a type of binary tree used for implementing priority queue. Okay, priority queue, when we want to implement, we will be using leftist tree. Okay, so this is the structure in C. First you have to define struct leftist node, and you will have key left and right, and you will have rank also, because we are using priority queue, right? After that, if you want to create a new node, what we will do is, we'll just define a struct star node, new node here, and using malloc we'll be allocating the memory here, and the key part we will be assigning the key which is passed here, and the left and right will be null, rank will be 1. Okay, new nodes will always have the rank 1 and return new node. This is the declaration of leftist tree node. Okay, after that this tree is given to us. See, in leftist tree, what is the thing is, here in the left part it should have more. Okay, it should have more depth than in the right part, then it is called as leftist tree. Okay, so in this case, what is the depth? 1 2. If we go 2 places, we'll reach the depth, but here 1 2 3, can go 3 places. So right is more and left is less. In this case it is not a leftist tree. Leftist means left should be more. So in this case it is a leftist tree. 1 2 3 is there here, but here only we have maximum only 2 here to reach the end. So this is a leftist tree. Okay, this is the same thing, you need to explain it here as well. Okay, moving on to the third super important question: explain static and dynamic hashing in detail. It's for 8 mark question. And also explain directory and directly less hashing. These two questions can be separate also, it can be in the same question also. So basically Very simple answer. You just have to remember what is static hashing. Here the table size is fixed. All you have to write is this much only. The table size is fixed. The table whatever we have, it is fixed. Okay, it will not increase or decrease. Okay. Example, linear probing and chaining. Okay, so these are the different collision resolution techniques. We'll be discussing that question as well. So this is the example. Okay, you can draw a diagram also if you have time. That will also help you to fetch more marks. Dynamic hashing. In dynamic hashing, size of hash table increases as the collision occurs. Collision means what? See, suppose that I enter a value in one place and another value came that also got the same index value. Okay, suppose that if I take 11 and 21, both if we find out the remainder when we divide by 10, we'll get the value 1. So first I stored 11 in first index, again 21 came. 21 also I had to store in first index. This is a collision because already 11 is stored there. Already 11 is stored in first index because of 11 divided by 10. Again 21 came, 21 also has to be stored. This is called as collision. When collision occurs, we will have to increase the size of the table. Okay, so the first one is using directory. Directory, what we do, you just have to make this diagram. Don't need to make any complex things. 00011011, A0 B0 A1 B1 C2 and C3. This is pointing to the following things. Now if any other comes, like for example c5 also needs to be stored here. Suppose in that case it cannot be stored here because maximum size is 2 here. We have to increase this length. So when we increase this length, another 3 blocks come here, so that another 4 blocks come here. In these 4 blocks we'll be able to store c5 also. Okay, so this is 101, right? The ending part is 1 here, and the ending part here also it was 1. Okay, so this is just an example. In this case the size increase, so there is an empty space here. Here also c5 can be stored. Also this also can be pointed to c2, this also can be pointed to c3. Okay, because it is equivalent. 111 is equivalent to c3 is pointed by this one, right? 011. Ending 2 digits, if it's same, both point to the same location. Okay, this example you can give and write the same thing what I explained. Okay, if the collision occurs, the size is increased, and if you use the directory, it is called dynamic hashing using directory. Second is without directory. In without directory, what we do, size of hash table is increased as well as pages are increased. Okay, so insert the order in linear hashing. So this is a question given to us: 1 7 3 8 12 4 11 2 and 1. This we have to insert. Okay, after insertion till 12. So suppose that we use linear hashing. Linear hashing means the same thing. We'll be dividing by 3. Okay, whatever the value is given to us, we can divide by 3, and when we store it. Okay, so suppose 1 divided by 3, what is the remainder? Remainder is 1. So with 1 I will be storing 1 here. 7 divided by 3, 1, again I will be storing here. 3 divided by 3, it is 0, so I'll be pointing with 0. 8 divided by 3, the remainder is 2, I'll store it here. 3 divided by 12, the remainder is 0, I'll be storing it here. Then 4 divided by 12, 4 divided by 3. What is the 4 divided by 3? It is 1. 1 cannot be stored here because max is 2 here. So in this case, the size has to be increased. So what we basically do is, first we will assign 4 here, then we will increase the size. Okay. After we add another space 3 and recalculate the hash value. See, we increase the space here. Okay, one space will increase at a time, so another space has been added here, and we'll be dividing by 6 now. Okay, because 3 is already present here, divide by 3, this and this will become same, so that's why we will divide by 6. Okay, so when we divide by 6, what answers we will be getting is, firstly, again we have to calculate the hash values for each of these. Okay, firstly we divide by 3 and assign these values. Now we have to double it. Okay, we have to add one value and double the divisor. So firstly we divided by 3, now we will divide by 6. Okay, we have to divide each of these numbers by 6 and assign the new values here. So when we divide 3 by 6, the answer is 3, so it will be assigned with 3. 12 by 6, the answer is 0, so it will be assigned with 0. 1 by 6, answer is 1. 7 by 6, answer is 7. 4 by 6, the answer is 1. The answer of 4 by 6, again I'll be recalculating for, so wait for some time. 8 divided by 6 is 2, so it will be assigned with 2. Now 4 is present here, we have to do something for the 4, right? So since 4 mod 6 is 4, we need to rehash the values and extend, because 4 answer we are getting but 4 is not present here, so we'll be extending again and we'll be putting it here. Okay, that's the final step. Okay, after that the remaining numbers which they had given, that also will be inserting. 11 2 and this is 10. Okay, not 1, it is 10. Okay, so let me make it 10. Okay, this is 10, so we'll be inserting 10. Again the same thing, if the remainder is not present, we'll have to rehash the values and extend the hash table. Okay, so I'll be just quickly going through it, what you need to do at the end. Okay, so this is the thing. After 11 2 and 10, all of them got assigned here, so 2 got assigned here, we need to change 2 also. Okay, so that will be continued. Okay, so you got the point, right? How do we do this one, right? So this is how we do it using directory less hashing. Okay, this is the directly list hashing. This two things are there in dynamic hashing: directory and directory list. Okay. Moving on to the next super important question, we have what is chained hashing. Okay, what is chained hashing? This is a type of hashing. Okay, discuss its pros and cons. Construct the hash table to insert the following keys in a chained hash of 9 memory locations. Okay, and the formula is given: h of k is equal to k mod m. Okay, this is for 10 marks. So step by step we'll go. First is what is chained hashing. Chained hashing is a technique in which a linked list is used to keep track of nodes with the same hash key. Okay, a linked list is used to keep track of nodes with the same hash key. Okay, that is what is called as chained hashing. And the formula given is h of k is equal to k mod m. Okay, so let's take m is equal to 9. Now, in a chain hash table, how do we insert the keys? Okay, so this is the keys given to us. Now, basically what we do is we'll just do the modulus 9 here. I mean modulus 10 because 9 places are there, so we do modulus 10 here. Okay, now 7 modulus 10, what it is? 7 modulus 10 is 7 only, so we'll place it here. Okay, and sorry, we'll not be doing modulus 10, we have to do modulus 9, right? Because there are 9 memory locations, it will be from 0 to 8. Okay, now when we do 7, we'll go to here, the remainder is 7. And next 24 modulus 9, what is the remainder? Remainder is 6. 18 modulus 9 remainder is 0. 52 modulus 9 is remainder 7. So what we do, we'll just join it like this. Okay, that is what is called chain hashing. 36 modulus 9 is 0. 54 modulus 9 is 0. 11 modulus 9 is 2. And 23 modulus 9 is 5. So we'll be inserting these things here. Okay, this is all what you have to make. After that, they had asked the pros and cons, right? So let's have a look at it. So pros, what you need to do, it handles collision efficiently. Why? Because it can store multiple values in a single place using a linked list. Okay, and dynamic storage, the storage issue is not there. We can keep increasing as much as we want by inserting new nodes, and it is simple implementation. Cons are each memory extra memory overhead, because every linked list requires additional memory for storing the pointers. So in the fixed one, we just have one place where all the things are stored, but here we need separate pointers for each of these places, right? That is a disadvantage. Poor performance in case of bad hash function. If the hash function is bad, it can take a lot of time. And cache unfriendliness, so the use of linked list can result in poor cache performance. Okay, moving on to the fifth super important question, which is write a short note on optimal binary search tree. Okay, they can ask you the numerical also in the optimal binary search tree. It has been appeared in the previous year paper, but that is a bit complicated. Okay, so that's why I have skipped and included those questions which are easier ones. Okay, so in case they ask you about the short note on optimal binary tree, what you have to write: optimal binary search tree is nothing but a binary tree that minimizes total cost of searching for elements. So let's take an example here. See here, if I want to search 10, I will first check if this is 10 or not, then I'll check this is 10 or not, then I'll check this is 10 or not. How many checks are made? 3 checks are made, so I'll written here 3. If I want to check if 11 is present or not, I have to make 2 checks here, I will get it from here. If I have to check 5 is present or not, I just have to make 1 check and I will get it. If it is present in this way also, 1, 2 and 3. In this way also 1, 2 and 3. In this way also 1, 2 and 3. But in this way, if I arrange, if I want to check for 10, I'll just check this one. If I want to check 5 or 11, I'll check first 10, and less than 10, if it is 5, it will be I'll get here. Greater than 10, I'll check here and I will get it. So the thing is, here in optimal binary search tree, this is having the least cost for searching the elements. Okay, that is what is called optimal binary search tree. And it's for 4 marks. You just have tried this one, it is sufficient. Okay, moving on to the last question of the DSA module 5, super important. We have what is collision, what are the methods to resolve collision, explain the linear probing with example. Now, what is a collision? Collision happens when you obtain same hash value for two different keys. There are two different keys, 291 and 31, and when we apply the hash function by modulus 10, we will get two hash values, 1 and 1, both are same. Cool. So this is what is called as collision. Now, what are the methods to resolve collision? Few methods are there to resolve collision. First is linear probing, second is quadratic probing, double hashing, rehashing, and chaining. Okay, these they have just asked us to mention how many are there. Okay, we need not explain it in depth, but linear probing they have asked in depth. Okay, if you read the question afterwards, explain linear probing with example. Now, with example, and they have either with they will give with example or they will give the keys itself. So I'll be explaining both together. Okay, so the keys also given here, I'll take this same example. Okay, now linear probing, what we have to do is firstly we have to write the definition. In this method, a remainder value is taken as key. What is taken as key? Remainder value. Whatever we do modulus, right? After that, we'll get an answer. That remainder, that is taken as key, and values are stored at those indices. Okay, so the answer which we get, the remainder, that index will store that particular value for which we have got the remainder. If it's already filled, next gap is taken. So you'll understand this when you solve this question. Okay, so here the key is given are 72 to 101. Okay, 72 to 101. And modulus 10 we have to do. They have given in the question. We have to do modulus 10. Okay, see. The size 10 is given, so we have to do modulus 10. Modulus 10 means from 0 to 9 we have to make. Okay, from 0 to 9. Now, 72. What is 72 modulus 10? 72 modulus 10 is 2, right? So we'll be putting 72 here. Next, 27 mod 10. 27 mod 10 is 7. And 36 mod 10 is 6. So I'll 24 mod 10 is 4. So I'll put 24 here. 63 mod 10 is 3. So I'll put 63 here. 81 mod 10 is 1. So I'll put 81 here. Now, next we have here 92. 92 modulus 10 is what? 92 is 72, but 72 is already occupied. So I'll check the next one. This is also occupied. I'll check the next one. This is also occupied. I'll check the next one. So I'll be putting it in the next space available. I'll put 92 here. Got my point. I got 92, but already 72 was filled. So I'll check the next one, next one, next one until I get a open one. I'll be filling that with the given value. Next, I have 101. 101. This is to be filled in 81 place because 101 modulus 10 is 1. It is filled, but here it is empty. So 101 will be stored here. Okay, this is all you have to write the final answer. Okay, that's all for this video, and please do like and subscribe. It helps me make more videos like this. Don't miss any question. These are super important ones, and thank you so much for watching. I'll see you in the next one.